Hello everyone. This is Dr. Kanchan Mani and today we will discuss the topic renewable energy resources. The topic, we will discuss, why is the renewable energy important? Then, solar energy and its principle, the photovoltaic effect, and further, the hydrogen as a future fuel. We use petroleum, coal and natural gas, which provide about 97% of the energy. But one of the important problems faced in the use of such sources of energy is the accompanying pollution. Also, these sources are diminishing and are not able to keep pace with the increasing demand for energy. As we know, sun is the most powerful and free source of energy. We receive the energy from sun in the form of heat and light radiations. The advantage is, sun give 1,000 times more power than we need. The photovoltaic effect is one way of tapping solar energy to tide over present energy crisis. The photovoltaic effect can be better understood from the knowledge of energy bands. The range of energies possessed by an electron in a solid is called energy band. There are 3 energy bands in solids as shown in figure. The first is valence band. The valence band is possessed by valence electrons. The next is conduction band. The conduction band is possessed by conduction electrons, and in between this two is forbidden energy gap, which cannot be occupied by the electrons. On that basis the metals are classified as insulators, conductors and semiconductors. The substance whose electrical conductivity lies in between conductors and insulator called semiconductors. Mostly, the semiconductors are used as solar energy converters. Semiconductors are of 2 types: P-type semiconductor and N-type semiconductor. A semiconductor with excess holes is called as P-type semiconductor, and when a small amount of trivalent impurity like boron is added to the pure semiconductor like silicon, form a 3 covalent bond, and absence of one less electron, create a hole. Therefore, they are called as acceptor impurities. Semiconductor with maximum electrons is called as N-type semiconductor. When a small amount of impurity from pentavalent element like phosphorus is added to pure semiconductor, it forms N-type semiconductor. Pentavalent element contains 5 valence electrons, 4 of which forming covalent bonds. The next point is p-n junction. The formation of p-n junction of semiconductor is very essential for the conversion of solar energy to electrical energy. This crystal of semiconductor material doped from one side by donor impurity and other side by acceptor impurity, then a p-n junction is formed. The p-n junction is the boundary region between 2 regions, one is rich in electron and other rich in hole. By absorbing the solar energy, additional electron-hole pairs are produced near the junction. These pairs reach the depletion region by diffusion. As a result, a current flows across the junction and passes through load. The principle used in this mechanism is called photovoltaic conversion. Now, let's move towards the next point, that is construction and working of solar cell. Silicon solar cell consists of 5 layers. First layer is encapsulate. The encapsulate is made of glass. The second layer is contact grid. It is made of metal, as a good conductor. The third layer is anti-reflective coating. A layer serves to guide light into the solar cell. Next is the N-type silicon, in which 1 extra electron is available for conduction. And the last layer is of P-type silicon, in which a hole is available for conduction. The last layer is called back contact, which is made out of metal, which covers the entire back surface of solar cell. The schematic diagram of silicon solar cell is shown in this diagram. Once the photon passes the anti-reflective layer, it will hit the silicon surface and extracts valence electrons from there. These freeze electrons unite with the holes on the p-type layer. Then, the p-n junction allows the electrons to move in one direction. The electron flow provides the current and the electric field causes the voltage. Therefore, when the external load like bulb, fan, computers, electricity flows in the cell, doing work for us. In this way the solar cell works. Now let's move towards the next point, that is, hydrogen as a future fuel. The hydrogen energy is a clean and inexhaustible energy like renewable energy and nuclear energy. So, the future energy technology will utilize hydrogen with an increasing trend in steady as well as unsteady combustion processes. Hydrogen is the most common element in the universe and can be made from water. Converting hydrogen into energy is compatible with existing energy technologies, such as fuel cells, engines and combustion turbines. Hydrogen is produced from fossil fuels, hydrocarbon polymers, biomass and water by electrolysis and the biological processes of photolysis or thermolysis. Hydrogen gas can be stored as a gas or a liquid. Hydrogen possesses properties that make it an ideal fuel. Hydrogen has a good properties as a motor fuel and it can be used in automobiles too. Hydrogen burns with a very hot flame and explosion in air. 2H2 plus O2 forms H2O.
Now, let's check out the hydrogen production process by direct electrolysis of water. Water electrolysis involves passing an electric current through water to separate it into hydrogen and oxygen. The reaction, check out the reaction here. The potential required to split water into H2 and O2 is equal to 1.229 volt. Though the theoretical potential is 1.23 volt, the extra potential that is 1.7 volt is essential due to overvoltage.